Welcome to the expanzPLATFORM How to Build an Azure Server video. In this video, we step through the process of building an expanzPLATFORM Azure Server using an application we created during the video series titled How to Build an expanzPLATFORM Application. In other videos in this series, we create an expanzPLATFORM server that runs on-premise, and also step through the unit testing functionality built into the platform. Let's get started. We have Visual Studio 2010 and expanzPLATFORM installed on this computer. From within Visual Studio, create a new project and select Expanz from the list of installed templates. And from the Expanz submenu, select Azure Server and click OK. The Expanz Studio project from previous videos created a .esp file. We named the project Sales, so the project file is called sales.esp. Select that file and choose Open. Next, we specify the database connection. Entering a database connection isn't mandatory, but it's convenient to configure that connection here. If you don't have a database yet, the Expanz runtime creates a database for you if you have permission to do so. Let's also choose to generate the entity framework objects and context classes so we can perform link queries. Click OK. Similar to creating the on-premise server, Expanz tooling creates scaffolding for Azure Server based on the metadata from the Expanz Studio project. Folders appear in Solution Explorer, seen on the right side of the screen, many of which are prepended with ESA, which stands for Expanz Server Architecture. The folders created are an Azure host with web and worker roles preconfigured, an Azure service, a session manager, a site manager, a testing project, and a folder for our application, which in this case is the sales folder. All our work will be done within the application folder, in this case the sales folder. Let's take a closer look. The sales project consists of subfolders that make up the elements of our application. The constants folder contains the application's activity definitions, enabling us to refer to them in code form, and a messages constants class, enabling us to refer to the application's messages in code as well. Next is the Entity Model Objects folder. expanzPLATFORM leverages the Entity Framework to provide link support for retrieving data. The Entity Framework has its own built-in ORM. For more complex data retrieval, or to avoid learning the Expanz ORM, we can use link to gain access to data. The Metadata folder is next. It contains the metadata that was built when working in Expanz Studio. This metadata is the heart of the application and is used at runtime. All objects are instantiated using the model object document, so if it doesn't exist in this document, it won't be available to clients at runtime. You can, however, still access plain old class objects server-side. The Model Objects folder contains the application's POCO classes, or plain old CLR objects. When we look at the customer model object, we see the fields that we defined, as well as the method we created in Expanz Studio. At the bottom of the folder list, we see that the project also has a config.xml file. This config file can be edited by hand or within Expanz Studio. Let's start the project. Notice that the project starts without having to write any further code. The solution starts and the Azure Dev Fabric binds all of the relevant infrastructure. Here is the Dev Fabric. As you can see, the service endpoint has been configured, and the consoles display the application server and site manager instances. Upon starting, the application server syncs the model objects with database objects and creates a database for the application. At this point, you're ready to build a basic CRUD client that interacts with this fully functional, ready-for-business server. Your cloud-based server is ready for interaction. In the next video, we take a look at the testing functionality that is built right into expanzPLATFORM.